Have you ever stopped to think about this little magic wand we all have lying around our living rooms? This thing, the remote control. We press a button and boom, the TV turns on, the volume goes up, the channel changes. It just works, but how? What is the secret sauce inside this plastic box that lets you command your electronics from across the room? Today, we're going to pull back the curtain and demystify the humble remote control. It's a journey into invisible light, secret codes, and some surprisingly clever engineering that you probably take for granted every single day. So grab your favorite remote, get comfortable, and let's dive in. It all starts with a simple press of a button. When you push down on, say, the volume up button, you're completing an electrical circuit. Think of it like flipping a tiny switch. Underneath that soft rubber keypad is a grid of contacts on a circuit board. Each button has a specific spot. When you press it, a conductive pad on the underside of the button touches two contacts on the board, closing the circuit for that specific command. This action tells the brain of the remote, a small integrated circuit or microchip, exactly what you want to do. It is the very first step in a chain of events that happens in a fraction of a second. This microchip is the heart of the operation, holding all the potential commands in its memory, just waiting for your instructions. So, what does this microchip do once it knows you want to turn the volume up? It generates a unique code. Every single function on your remote, from power on-off to changing the input, has its own distinct binary code, a sequence of ones and zeros. This is like a secret language that only your TV or whatever device it's for can understand. The microchip's job is to translate your button press into this specific digital message. For volume up, it might be a sequence like 11,010,010. For channel down, it's a completely different one. These codes are incredibly important because they prevent your remote from accidentally controlling your neighbor's TV or your Blu-ray player when you trying to adjust the volume on your soundbar. It's a system of unique digital keys for unique digital locks. Now, we have a code, but how do we get it from the remote in your hand to the TV across the room? This is where the magic of invisible light comes in. At the very tip of your remote, you'll see a small bulb. It looks like a tiny LED, and that's exactly what it is, but it's a special kind, an infrared or IR LED. Infrared light is part of the electromagnetic spectrum, just like the visible light we see all around us, but its wavelength is just a little too long for our eyes to detect. The microchip sends the binary code to this IR LED. For every 1 in the code, the LED flashes on. For every 0, it stays off. It does this incredibly fast, creating a precise pattern of light pulses. So that binary code we talked about, 11,010,010, is transformed into a rapid sequence of on-on-off, dash-on-off, dash-on-off light flashes. You can't see it, but if you could, it would look like a tiny frantic beacon sending out a secret message in Morse code. A fun trick is to point your remote at your phone's camera and press a button. Most phone cameras can actually pick up this infrared light, and you'll see the little LED flashing on your screen. Go ahead, try it. It's a cool way to see the invisible at work. This stream of invisible light pulses now has to travel across your living room. Infrared light travels in a straight line, which is why you generally have to point the remote towards the device you want to control. If something is blocking the path, like a stack of books, a pillow, or your pet cat deciding it is the perfect time for a nap in front of the TV, the signal can't get through. This is called line-of-sight technology. Some high-end remotes use radio frequencies, or RF, which can pass through walls, but the vast majority of remotes that come with your devices use this line-of-sight IR method because it's just simple, reliable, and very cheap to manufacture. The light beam also spreads out a bit as it travels, like the beam of a flashlight. This is why you don't have to have sniper-like aim. As long as you're pointing in the general direction of the device, the beam is wide enough for the sensor to catch it. So the light pulses have made their journey. What happens on the receiving end? On the front of your TV, your cable box, or your sound system, there's a small, dark plastic window. Behind that window is an infrared receiver or sensor. This sensor's one and only job is to detect those incoming IR pulses. It's tuned to look for light at that specific infrared frequency. When the flashes of light from your remote hit this sensor, it converts them back into an electrical signal. The pattern of on and off flashes is translated back into the original binary code, that sequence of ones and zeros. It's the reverse of what happened in the remote. The light message is received and turned back into a digital message that the device's main processor can understand. This receiver is also designed to filter out other sources of infrared light, like sunlight or heat from a lamp, so it only pays attention to the rapid, coded signals from your remote. Once the TV's internal processor receives that binary code, it acts like a bouncer at a club, checking a guest list. It looks at the code and checks it against its own internal library of commands. It asks, is this a valid code for me? And what does this code mean? If the code is, for example, the one for volume up, the processor says, "Ahaha, I know this one," and then it executes the corresponding function. It sends a command to the TV's audio circuitry to increase the amplifier's output, and you hear the sound get louder. All of this, from the moment you press the button to the moment the volume changes, happens in what feels like an instant. We're talking milliseconds. It's a beautiful, seamless process. The processor will only respond to the codes it's programmed to recognize. That's why your Sony TV remote won't work on your Samsung TV. They speak different languages, or rather, they use different sets of codes. Now let's talk about something a little more advanced. Universal remotes. How can one remote control your TV, your cable box, and your sound system, all from different manufacturers? The concept is the same, but the execution is smarter. A universal remote has a much larger brain and microchip with a huge library of codes for thousands of devices from hundreds of brands. When you first set it up, you have to tell it what devices you have, usually by entering a specific setup code from a manual, or by having the remote automatically search for the right one. Once programmed, the universal remote knows which set of IR codes to use for which device. When you press the TV button and then volume up, it sends the volume up code for your specific TV model. Then you press the cable button and channel up, and it sends the entirely different channel up code for your cable box. It's like a multilingual translator, able to speak the unique infrared language of each of your devices. Some modern smart remotes even use Bluetooth or Wi-Fi alongside IR, giving them even more power and removing the line of sight limitation. So let's recap the entire journey. You press a button. A microchip inside the remote generates a unique binary code for that command. This code is sent to an infrared LED, which translates the code into a series of invisible light pulses. These pulses travel in a straight line across the room. An IR receiver on your TV or other device detects these light pulses and converts them back into the binary code. Finally, the device's main processor reads the code, understands the command, and executes the action, like changing the channel or muting the volume. All of that complexity, all of that technology, hidden inside a simple device that we use without a second thought. From a simple button press to a command executed across the room, it's a perfect symphony of simple physics and clever code. The next time you're channel surfing from your couch, take a moment to appreciate the incredible, invisible journey your command is taking. It's a small piece of everyday magic right in the palm of your hand. Thanks so much for joining me on this deep dive into the world of remote controls. If you found this interesting and want to see more videos breaking down the tech we use every day, make sure to hit that like button and subscribe to the channel. Let me know in the comments what piece of technology you'd like me to explore next. Until then, stay curious.